Have you ever heard of tetration? Most of us know addition, multiplication, and exponentiation. But did you know there's a next operation? One that's so powerful it almost never shows up in real life? Today we'll explore tetration, the operation that grows faster than anything you've ever seen, and why it's too powerful for everyday math.
But strangely, we never use it in our daily math. Stick around, because in a couple of minutes, you'll understand exactly why.
Let's start with what we already know. Addition means repeated counting. 2 plus 3 equals 2 plus 1 plus 1 plus 1 equals 5. Multiplication means repeated addition. 2 times 3 equals 2 plus 2 plus 2 equals 6. Exponentiation means repeated multiplication. 2 to the third power equals 2 times 2 times 2 equals 8. So what comes next? Repeated exponentiation. And that's what tetration is.
Tetration is written like this, with n copies of a stacked in the exponents. For example, 3 tetrated 1, that's equal to 3 to the power of 1, which is 3. 3 tetrated 2, that's equal to 3 to the power of 3, which is 27. 3 tetrated 3, that's equal to 3 to the power of 3 to the power of 3, which is 3 to the power of 27, and that equals 7,625,597,484,987. That's already over 7 trillion using just 3 threes. Now imagine 3 tetrated 4. That's equal to, well, 3 to the power of 3 to the power of 3 to the power of 3, which is 3 to the power of 7,625,597,484,987. Can you imagine that number? That number is so huge that even a supercomputer couldn't write all its digits.
Let's compare growth rates. Addition, 2 plus 4 equals 6. Multiplication, 2 times 4 equals 8. Exponentiation, 2 to the power of 4 equals 16. Tetration, 2 tetrated 4 equals 2 to the power of 2 to the power of 2 to the power of 2 equals 65,536. That's just 5 twos, and it's already over 65,000. Add one more level, and it's a number with 19,729 digits. Tetration doesn't just grow fast, it explodes in size.
So if tetration is so powerful, why don't we use it in everyday math? Here's why. 1. Numbers get too big to handle. Even with small inputs, tetration produces numbers larger than the atoms in the universe. That makes them impossible to calculate or apply. 2. Real-world systems don't grow that fast. Populations, economies, or physics all grow exponentially at most. We rarely face situations needing growth beyond exponentiation. 3. It's hard to visualize or interpret. While multiplication means groups and exponentiation means powers, tetration doesn't have a natural physical meaning in daily life. 4. It's mostly theoretical. Mathematicians study it in hyperoperations, computational theory, and advanced number analysis, but it's not needed for business, science, or engineering, yet.
So the next time you see a simple exponent, remember, it's just one step on a ladder that reaches far beyond what we can imagine. Tetration may not rule the real world, but it rules the imagination. If you enjoyed this, hit subscribe and join us next time for another journey into another mystery.